In the heart of Texas, something extraordinary is happening. Every 40 seconds, a brand new Tesla Model Y rolls off the production line at Gigafactory, Texas. That's faster than you can make a cup of coffee. But here's what most people don't realize. This represents the biggest manufacturing breakthrough since Henry Ford's assembly line. And the implications go far beyond just building cars faster. Today, we're going deep inside Tesla's most ambitious factory to understand how they've managed to crack the code that every automaker has been chasing for decades. Because what you're about to discover could determine which companies survive the next decade of manufacturing. Tesla's Gigafactory, Texas opened its doors in April 2022, but the story of this facility begins much earlier. When Elon Musk first announced plans for a Texas factory in 2020, most industry experts were skeptical. Tesla was already struggling to meet production targets at their other facilities, and here they were promising to build the world's largest car factory by volume. The plan seemed almost impossible. A single facility that could produce over 1 million vehicles per year. Traditional automotive executives dismissed the timeline as typical Musk hyperbole. After all, building a new car factory typically takes 5 to 7 years from groundbreaking to full production. Tesla was claiming they could do it in less than 2 years, while simultaneously revolutionizing the manufacturing process. But Musk had learned something crucial from Tesla's earlier production struggles at their Fremont factory. The problem wasn't just about building cars faster. The entire approach to automotive manufacturing was fundamentally flawed. Traditional car factories, even the most modern ones, still follow principles established in the 1920s. Cars move down a linear assembly line, with workers and robots adding components at each station. Henry Ford's revolutionary concept had remained largely unchanged for a century. But Tesla's breakthrough came from asking a completely different question. Instead of, how do we make this assembly line faster, they asked, what if we eliminated the bottlenecks entirely? The answer lies in what Tesla calls their alien dreadnought manufacturing philosophy. Picture this. Instead of a single long assembly line, Gigafactory Texas uses multiple parallel production streams that can operate independently. Meaning if one stream encounters a problem, the others keep running. Think of it like having 4 highways instead of 1. If there's an accident on one road, traffic keeps flowing on the others. But the real innovation goes much deeper than just parallel lines. Tesla's fundamentally changed how cars are assembled by focusing on what they call structural battery packs. In traditional electric vehicles, the battery is essentially a heavy box that gets bolted to the bottom of the car. The battery serves one purpose: energy storage, while adding significant weight and complexity. Tesla's breakthrough was making the battery pack itself part of the car's structure. Just think of the difference between carrying a heavy backpack and wearing a bulletproof vest. The backpack is dead weight you have to carry, but the vest becomes part of your protection system. Tesla's structural battery pack doesn't just store energy, it actually makes the car stronger and lighter simultaneously. This seemingly simple change has massive implications for manufacturing. When the battery pack is structural, you can build the car in large sections that snap together like industrial Legos. The front section, the middle section with the battery, and the rear section can all be assembled simultaneously in different parts of the factory, then combined at the end. And the statistics are staggering. A traditional automotive factory might have 3,000 to 4,000 individual parts coming together on the assembly line. Tesla has reduced this to fewer than 1,000 major components. Fewer parts means fewer suppliers to coordinate with, fewer things that can go wrong, and dramatically faster assembly times. And this reduction in complexity allows Tesla to achieve that remarkable 40-second production rate. They're not building cars sequentially anymore. They're building them in parallel, with multiple vehicles at different stages of completion moving through the system simultaneously. But Tesla didn't stop at redesigning the car. They redesigned the machines that build them. You see, most automotive equipment is purchased from specialized suppliers who have been making the same basic machines for decades. These suppliers have little incentive to innovate because their customers are locked into traditional manufacturing processes. Tesla decided to design and build their own manufacturing equipment in-house. Walk through Gigafactory, Texas, and you'll see robots and machines that don't exist anywhere else in the world. Tesla's engineers designed these systems specifically for their new manufacturing process. While other automakers are constrained by what equipment suppliers offer, Tesla can create exactly the tools they need. And this vertical integration extends to software as well. Tesla writes the code that controls their manufacturing equipment, allowing for rapid updates and improvements. Traditional factories often rely on decades-old software that's difficult to modify. Tesla can push updates to their production line like a smartphone app update. The scale of this operation is mind-boggling too. Gigafactory, Texas covers 2,500 acres, larger than 1,800 football fields. The main building alone spans over 4 million square feet, making it one of the largest buildings in the world by footprint. To put this in perspective, you could fit 75 football fields inside the main production facility. And the factory operates 24 hours a day, 7 days a week. And at peak production, it employs over 20,000 people working in coordinated shifts. But unlike traditional factories where workers perform repetitive tasks, Tesla's approach requires a more skilled workforce. Employees need to understand multiple aspects of the production process because the parallel manufacturing streams require greater flexibility and problem-solving abilities. Tesla's also revolutionized quality control. Traditional factories inspect cars at the end of the assembly line. And by then, if there's a problem, you already wasted time and materials building a defective vehicle. Tesla's system monitors quality at every step using thousands of sensors and cameras placed throughout the facility. Artificial intelligence analyzes this data in real time, catching potential issues before they become problems. Machine learning algorithms can predict when a robot might need maintenance or when a particular batch of materials might cause quality issues. This predictive approach prevents problems rather than just detecting them after they occur. And the environmental implications are equally impressive. The factory runs entirely on renewable energy, with one of the largest solar installations in the US covering the roof. Tesla estimates that Gigafactory, Texas achieved carbon neutrality within its first year of operation, something unprecedented in traditional automotive manufacturing. Water usage has been reduced by 70% compared to traditional factories through advanced recycling systems. Even the paint process has been redesigned to eliminate volatile organic compounds while reducing energy consumption by 40%. And perhaps the most significant breakthrough is in cost reduction. Tesla's managed to reduce the cost of manufacturing a Model Y by approximately 50% compared to their previous generation factories. This reduction comes from a few different sources: fewer parts, less labor per vehicle, reduced energy consumption, and elimination of waste in the production process. And these cost savings give Tesla enormous strategic flexibility. They can either maintain current prices and enjoy higher profit margins, or reduce prices to gain market share while maintaining profitability. As you can imagine, this puts tremendous pressure on competitors who are still locked into higher-cost manufacturing processes. The ripple effects of this breakthrough extend far beyond Tesla. Every major automaker is now scrambling to understand and replicate Tesla's manufacturing innovations. Ford has announced a $50 billion investment in new manufacturing technologies. General Motors is completely restructuring their production processes. Even luxury brands like BMW and Mercedes are rethinking their approach to factory design. However, copying Tesla's approach isn't as simple as just buying new equipment. The success of Gigafactory, Texas required a fundamental cultural change in how Tesla thinks about manufacturing. Traditional automotive companies have decades of institutional knowledge built around linear assembly line production. And changing to Tesla's approach requires completely retraining workers, redesigning supply chains, and rethinking basic assumptions about how manufacturing works. Tesla's success in Texas hasn't been without challenges. The complexity of coordinating multiple parallel production streams initially led to quality control issues. In the first 6 months of operation, Tesla had to slow production several times to address problems with paint quality and panel alignment. Critics argued that Tesla was moving too fast and sacrificing quality for speed. But Tesla's response demonstrates another key aspect of their manufacturing philosophy: rapid iteration and improvement. Instead of shutting down for months to fix problems, they implemented solutions while continuing to produce vehicles. And by the end of 2022, quality metrics had improved dramatically, and production rates were exceeding targets. The facility's success has also created unexpected regional challenges. The demand for skilled workers has created a talent shortage in the Austin area, driving up wages across the tech and manufacturing sectors. Local infrastructure has struggled to keep up with the rapid growth, leading to traffic congestion and housing shortages. And Tesla's breakthrough has implications that extend far beyond the automotive industry. The principles they've developed, parallel production, structural integration, in-house equipment design, and real-time quality monitoring, are being studied by manufacturers in aerospace, electronics, and construction. Boeing has sent teams to study Tesla's approach to parallel assembly. Apple is examining Tesla's quality control systems for potential application in electronics manufacturing. Even construction companies are looking at how Tesla's modular approach might apply to building homes and commercial structures. The financial impact of Tesla's manufacturing breakthrough is already becoming clear. In 2023, Tesla's profit margins on vehicle sales exceeded those of traditional luxury automakers, despite selling cars at significantly lower prices. Tesla's gross margin per vehicle is now higher than Mercedes-Benz or BMW, while their average selling price is roughly half. This financial advantage allows Tesla to invest heavily in research and development, while competitors struggle with thin margins. Tesla can afford to take risks on new technologies because their manufacturing efficiency provides a financial cushion that traditional automakers lack. Looking ahead, Tesla plans to apply these manufacturing innovations to their upcoming Cybertruck and next-gen vehicle platforms. The company has announced plans for additional Gigafactories using the same principles in Mexico, India, and potentially other locations. Each new factory will incorporate lessons learned from the Texas facility, making them even more efficient. But perhaps the most intriguing possibility is what happens when Tesla's manufacturing expertise meets other industries. There are already discussions about Tesla potentially licensing their manufacturing technologies to other companies, creating an entirely new revenue stream. The broader implications for the global economy are significant. If Tesla's approach becomes the new standard for manufacturing, competitive advantage could shift away from countries with low labor costs toward those with advanced technology infrastructure and skilled workforces. This could fundamentally alter global trade patterns and manufacturing strategies. As we stand at this inflection point in manufacturing history, Tesla's breakthrough in Texas represents more than just faster car production. Every 40 seconds, another Tesla rolls off the line, not just as a car, but as proof that the impossible is just another engineering problem waiting to be solved. The question isn't whether other companies will adopt these innovations, but how quickly they can adapt before they're left behind. What started as an ambitious plan to build cars faster has evolved into a complete reimagining of manufacturing itself. What do you think about Tesla's manufacturing revolution? Will traditional automakers be able to catch up, or has Tesla created an insurmountable advantage? Let us know your thoughts in the comments, and we'll see you in the next video.